Get a little practice with that today too. But today I want to talk about, take that one step further, and we're going to talk about simplifying square roots of fractions. Okay, so let's take a look at a couple examples here. What if we've got something, let's take the top one. If I have the square root of 9/4, what do you suppose I can do to a square root of a fraction? Is there a way you suppose I could break that apart? Say it again. Make it 2 square roots. Yeah, just like we did yesterday, we said that the square root of a product we could break apart into separate square roots. We can do the same thing with a quotient. So we could rewrite this as the square root of 9 over the square root of 4, which is what? What's the square root of 9? 3. Square root of 4? 2. Good. Okay. Make sense? And we're done. Okay, that's it. That's a pretty easy one. What about one like the next one down? What about something like that? 32 is not a perfect square.
16 is.
And 2 is not a perfect square, but what did you see?
32 divided by 2.
Ah, very good. Okay, so you can also look at the fraction that's inside the radical and see if you can just reduce that fraction or simplify it, right? So 32 over 2 is 16, right? So the square root of 16 equals
4.
Done. Okay, right? So sometimes we can do that trick. Sometimes we can do neither trick, like the bottom one. Look at the bottom one here. Now, if 8 over 5 does not simplify, right? So I've got to split this one apart. So I get square root of 8 on the top and square root of 5 on the bottom. So what we'd always like to do when we're dealing with a square root of a fraction, we always want to get the square roots as small as possible before we do anything, right? What about the square root of 5? Is there a perfect square factor of 5? There is not, right? Is there a perfect square factor of 8? And when we say perfect square, what do we mean? What's a perfect? Give me an example of a number that's a perfect square. 4, because 2 squared is 4. Give me another one. 9, because 3 squared is 9, right? So is there a perfect square factor of 8? A perfect square that divides evenly into 8? 4 does, right? 4 does. So we could rewrite this as, we always want to put the square root of the perfect square first, right? When we split it apart. So square root of 4 times square root of 2, right? The square root of 8 split into those two. Then on the bottom, we're kind of stuck with that square root of 5. What's the square root of 4? 2. Okay, so that was good. We did something valuable there. So we got we reduced the square root on top. Now on the top, we've only got a square root of 2 to deal with instead of a square root of 8, right? On the bottom, we're stuck with a square root of 5. Okay, now this looks like maybe we're done because we can't really go any further, but we're not. There's a rule in math, we can't have an irrational denominator, meaning we can't have a square root on the bottom. Okay, so if we ever have a stranded square root on the bottom, we've got to do something to get rid of that, okay? But think about this whole process here. Notice that each of these steps is linked by an equal sign. So would you agree that if I were to plug this expression into the calculator and hit enter, I'm going to get a decimal back? When I'm all done with this, if I put my answer in to a calculator, should the decimal be any different? Can't be, can it? It's got to be the same decimal. All we're doing here is we're changing the form of this answer, not the value, right? We're simplifying the answer in the same way that if we have something like, would you agree on this one up here? If I put in the square root of 9 over 4, I'm going to get 1.5. If I put in 3 divided by 2, the calculator is also going to tell me 1.5. You see what I'm saying? It's not like the value of the number has changed. We've just simplified it so it looks better and simpler, right? Okay, so we got to add another part to this, though. We've got to get rid of that square root of 5 on the bottom. Any ideas what we could do? Okay, good, very good. So there's not much we can really do here, but one thing that we do a lot in math is we multiply by 1. Because multiplying by 1 doesn't change the value of a number, right? So multiplying by 1, but the 1's not just as a 1. Just multiplying by 1 doesn't change anything. If I think of it as a fraction though, would you agree that any fraction that has the same thing on top and bottom is equal to 1, right? So we're going to multiply by a fraction with the same thing up here and down there, right? But what we put there is determined by what's already on the bottom. What could I multiply the square root of 5 by to get rid of the radical, to get a number that wouldn't have a square root? Square root of 5, yeah. If I multiply the bottom by the square root of 5, that's going to be helpful. Let's think about what that does. A couple ways you could look at this. If I multiply the square root of 5 times the square root of 5, I get the square root of what bigger number? 25. And the square root of 25 is? 5. Okay, an easier way to think about that though is the square root of 5 times the square root of 5. If I just multiply something by itself, what's an easier way of saying that? Like x times x would be what? X squared, right. So multiplying the square root of 5 times the square root of 5 is really just the square root of 5 squared. Well, what happens when you multiply, or when you take you square a square root, or you take the square root of a square? What do they do? Yeah, they cancel, right? And so that just leaves you with the 5. So that's a trick we can always do. If I ever multiply a square root times itself, that's one way to just cancel out the square root, right? I've got to do the same thing on top though, because I'm multiplying by 1. But you see what the benefit is. Then on the bottom, what do we get? 5. Yeah, the square root times the square root cancels, and I get a 5. And on the top, what do I get? No, I'm just going to multiply straight across when I multiply fractions, right? So what's 2 times the square root of 2 times the square root of 5? Now before you answer, let me just remind you about something that you already know how to do. Like if I multiply 2 times 3 times 4, what's the answer? 24, right?
4.
How'd you get that?
3 times 4 times 2.
Okay, you could do 3 times 4 is 12 times 2. Or you could also do 2 times 3 is 6 times 4, right? Or you could even do what else?
2 times 4 times 3.
Yeah, 2 times 4 is 8, times 3 is 24. So the moral of the story is, when you multiply more than one thing, you still just multiply sequentially in pairs. The order doesn't matter though, right? So what about up here? If we're going to multiply these together, what would probably be the most convenient ones to multiply together first?
2 and 2.
The square roots, right? Square root and square root. So what's the square root of 2 times the square root of 5? Square root of 10, right? So on the top, I just end up getting 2 times the square root of 10. And then we'd have to just look at that and see if we can do anything else, and we can't. 2 over 5 doesn't reduce, and the square root of 10 is done. There's no perfect square factor of 10. So that would be our answer. Okay? Notice that now we no longer have a radical on the bottom. That process is called rationalizing the denominator. Okay? Not that you really need to know that.
So
But
is it going to be over there?
yeah. So let's try just those 2. And then I'll unleash you on the assignment here. So in your notebooks, try this. This one's, I mean, it's not too bad. If you can do this one, you can do any of them. That one's harder. I mean, it's not horribly difficult. None of these are really horribly difficult. But if you can do that, you can do any of them. So try those real quick. Okay, so the bottom one, we got it down to here, right? Square root of 98 over square root of 27. We're looking for perfect square factors of 98 and 27. We'll just work individually on each one. Well, let's take the 98. 98 is not a perfect square, right? It's not a perfect square, so then if we're looking for perfect square factors, we can limit our search to just half of 98 and below. Half of 98 is 49, which is actually on our list. That's a perfect square, right? So the bottom we can rewrite as the square root of 49 times the square root of what? Well, 49 times what is 98? 2. Okay, what about the bottom? 27 is not a perfect square. Half of 27 is like 13.5 or something, right? So we know that we don't even, 16 is too big, so we'll just look from 9 on down. Does 9 go into 27? It does. So we can split the bottom into the square root of 9 times, 9 times what is 27? 3. Okay, good. And then what does the square root of 49 become? Good, and the square root of 9 becomes 3, right? So that's good. We got rid of a lot of the stuff under the radical. And now we're just stuck with a square root of 2 on the top and a square root of 3 on the bottom, right? Okay, so last step. That's pretty good. I know this is a really common thing to do is people immediately just say, okay, well, I'll multiply top and bottom by the square root of 27, which gives you a 27 on the bottom, but it gives you a huge number inside the radical on the top. That's really hard to deal with, right? So we always want to see if we can first whittle down what's inside the radical to something really small, and then the math becomes much easier. So what am I going to multiply top and bottom by here and why? Everett, what do you think?
Square root of 3.
Square root of 3. Good, because look what's stranded on the bottom. We have the stranded radical, the square root of 3. So that means we multiply top and bottom by square root of 3. So on the bottom, let's multiply these in a convenient order. What am I going to get on the bottom? What do I multiply first? Square roots. Square root of 3 times square root of 3 is what? 3. So I've got 3 times 3, so the bottom is 9, right? What about the top? Square root of 2 times square root of 3 is what? Yeah. Square root of 6, which I can't do anything with, so I've got 7 times the square root of 6. And that's my answer. Can't go any further than that. Right? That's a pretty hard one. If you can do that one, you can do any of them. Okay. Question?
So you did 3 times 3, so why would you do 7 times 6?
I get square root of 3 times square root of 3 is square root of 9, which is 3, right? So on the bottom, I've got 3 times 3 is 9.
So why can't you do 7 times 6?
Okay, because the 7's outside the radical and the 2's inside, right? So on the top, I'm multiplying 7 times the square root of 2 times the square root of 3. Well, the square root of 2 times the square root of 3 becomes the square root of 6. And then I can't really do anything else with that. I've just got 7 times the square root of 6, right? The 7 and the square root of 6, I can't do anything fancy with those, right? Make sense? Okay, have at it. I got a short assignment up there. I think it's only like 8 problems. It gives you a little practice with those things.